Okay. So now we are going to be just graphing lines, like putting it all together, right? Like I said, we did this in grade 9, so I'm hoping a lot of this will be review, but it's just at a harder level now, right? Okay, so we know how to find slope. If we go down, so the only thing that's going to be kind of an issue, you guys have done ones like this where we have to graph ones like this from a table, and we'll go through some examples like that one too, right? But as we get going here, what we're going to have to do is we'll be graphing things like this. And you guys see how they're not laid out in that nice y is equal to mx plus b form yet? So we'll have to do a little bit of algebra when we get to that. So yeah, we won't be doing too much of that yet, but it will come up a little bit. So if we're graphing linear equations with 2 points, then... So with 2 points, then really all we're going to be doing, guys, so you can like look through this one, but the idea is if we had something like y is equal to x plus 3, then we can always graph a line by actually just throwing in whatever number we want for x, right? You could throw in 1, 2, 0, you could throw in 1,000,000, you could throw in like negative 54, like any number you like, and then we plot that point. And then we do it again for another point, and then we just connect the points, right? So if I did this one, if I threw in, like the example here, -2 in for x, then that would be -2 plus 3. So that would be y is equal to 1, right? So then that's this, right? So if I put in an x value of -2, I get out a y value of 1, right? So I plot that point. And then do it again for the other one. So if we do it again for an x value of 2, that would be y is equal to 2 plus 3. So y is equal to 5. So that point would be at 2, 5. So you plot that point and then just connect the points. Right? So method 1. Why is the continuous line? Because you can put any number you like in for x, right? So this goes forever this way. Because I could put like all the way, like almost up to infinity in that spot for x, right? So it would go forever that way, and it would go forever the other way. Okay, so that's method number 1. The other way to do it is to plot a point and then just use our slope to kind of figure out where the next point would be. Just kind of go like up 5 over 2 or whatever the slope was in that case. So I think just to do some examples on that one. Okay, so draw the following line. So it says the graph of a linear function has a slope of 3 over 5 and goes through the point 0, -4. Okay, so what we want to do here, what do we want to do here? What do you guys have any ideas? Okay, yeah, we'll do that first. We want to make the Cartesian plane. So we'll say 0, negative, so we have to have some negative. Let's do that and that. All right, so what do you guys think? How can we do this one? Oh, that was terrible. Guys, let's change our line. All right, we're going to change our line to that to make it a little bit better. Okay, so it seems like some of you guys are maybe getting there. What I would do is plot the point, well, point K there, 0, -4. So the point 0, -4 would be at 0 and then down there. So K. And then what from there? How can I use this slope to figure out? Yeah, so I know this thing goes up 3 over 5, right? So I'm going to count up 3 and then over 5. So the next point would be there. So then just connect the lines, or connect the dots, I mean, sorry.
Wait, do we have to show that?
Yeah, technically you should. Yeah. So now let's look at the next one. So that's the first point there. So let's look at B. So if we were going to graph this line, notice that the form that it's in, right? This looks a lot like our y is equal to mx plus b. Right? So I can see in this form that my slope is negative 4 over 3. Do you guys remember the significance of our b value? What is our b value on this? Perfect. It is. It's going to be the y-intercept, right? It's worth maybe reviewing why this is the y-intercept. Here, if we threw, well, if I'm looking at the y-intercept here, right, like where this thing lands on the y-intercept, then can you guys see that our x value on the y-intercept, that'd be equal to 0, right? So if I just threw 0 in for x there, then that would be, well, anything. So this was negative 4 over 3, but anything times 0 is 0, right? And all you have left is 2, right? So then y would come out as 2 there. So that's why that's always going to be our y-intercept, is that b value, right? It's our constant term. Okay, so it's going to be at 2. So I know I have a point at 2. So at 2 is where we're starting. And then where from there? Yeah, rise over run. So
Down 4 up or down 4 over.
right, down 4 over 3, right? Because it's negative 4 over 3. So I'm going to go down 4. So just count down 4 over 3. And that's going to be my new point.
So is this perpendicular?
We could. No, it's not. How do you know it's not perpendicular?
Oh, because right angle.
Yeah, and we can look at our slopes, right? They're not negative reciprocals of each other, so those are not perpendicular. Okay. X and Y intercepts. So if we started off with, like, let's say 3x plus 5y is equal to 15, like the question here, and it says what is our x-intercept and what's our y-intercept. So remember, if I'm looking, like I just said, like if I'm looking for my y-intercept, then my x value would be equal to what?
3.
So at my y-intercept, this will, like if I look at this, right, this point here would be, well, 0, 3, right? The example they gave us here. Do you see how on our y-intercept, our x value would always be 0, right? And it's just the opposite with our x-intercept. On this one, this would be 5, 0. So our y value is equal to 0. Yeah? Does that make sense? Like your up and down is going to be 0 for that. So if I'm looking, let's say like in this case, if I was looking for my y-intercept, then all I'm going to do is I'm going to throw 0 in for x. Right? So this would be like 3 times 0 plus 5y is equal to 15. And that's nice, right? Because if I throw 0 in there, anything times 0 is 0, right? So that just really canceled. So if you notice that, you could have just canceled that right off the bat, not even dealt with it. So then you've just got 5y is equal to 15. So if I want to get y on its own, what do? Divide both sides by 5, and I'm done. So divide by 5. So y is equal to 3. So then, remember what this is saying. This is saying when x was 0, y was 3. So that's the point 0, 3. So that's our y-intercept. If you were looking for your x-intercept, what would you do? So if you're looking for your x-intercept this time, so this one was finding our y-intercept. This one's going to be finding our x-intercept. Right, so I'm just going to throw 0 in for y.
And then it'd be 3x equals 15.
Right, so then that really cancels, right? So we've got 3x is equal to 15.
And x is 5.
So then divide by 3, so x is equal to 5. So do you see how, so then in the end, right, when x is 5, y is 0. So that's our x-intercept. Okay? All right. I probably should have just done it for this for this one. You know what? I'm going to pause it. Can you guys do it? Okay. So if you're watching the video, look that over, pause it.
Oh, I did.